Architecture. API Layer Optimization. API stands for Application Programming Interface. Consider the list of features on the right. We can build a well-rounded API from this list of features by first grouping them, and then designing a module for each of the related components. Onboarding, usage, administrator. These individual APIs would fit into a larger picture. For example, the back end, as opposed to the front end, probably connected to a database. What normally goes wrong in this process? In an attempt to write less code, we sometimes write more. When we do not define clearly when one API should stop and the next begin. When each API is not seen in the whole context. Consider the following. We have an API with 3 layers. API layer 1 performs security, validation, an independent operation, notification, and logging. Layer 2 also provides security, validation, a different operation, more notifications, and more logging. The third layer does the same again, security, validation, operation Z, notification, logging. All of these layers have been implemented as if they were what I like to call the edge layer. This happens more often than you might think. When someone starts working on an API without the context of the whole, usually they do just this. Edge versus inner APIs. Consider the following example. API layer 1, security validation, and operation X. Layer 2, operation Y. And layer 3, operation Z, notification, and logging. This really isn't that complicated, and there are some varying philosophies about how much duplication should exist at each layer. But most of the time, it's simple stuff like this that flies under the radar. I'm not suggesting that all duplicate code should be eliminated. That's not the goal and not a good idea. In fact, the pursuit of removing all duplicate code has very negative side effects as a whole. By looking at each API in context of the whole, we save engineering time, cloud resources, and lower our maintenance load.